Thank you all very much for tuning into this BIR webinar. I believe it's the first of the kind, so I hope you find my presentation certainly enjoyable and stay tuned in. I've put a brief agenda up on the screen here so that you've got an idea of what I'm going to discuss throughout the presentation, and like I said, hopefully there's some interest there that you can remain tuned into this webinar. So let me start at the beginning. I'm John Shanley. I'm head of the international planning for Siemens Healthcare. I've worked for Siemens for 20 years, and for my sins, unfortunately, I've probably worked on most of the PFI and MES projects throughout the UK. At the moment, I'm in the throes of doing several different projects for around the world, including Saudi Arabia, China, Japan and Singapore, and obviously in doing so working with some of the leading healthcare architects and design teams. So I thought I'd better just demonstrate the purpose of my presentation, and it's really just to highlight some of the potential planning problems that we have when we're designing rooms and individual departments, and also some of the basic pre-installation requirements. So I thought I'd start with room sizes and workflow. This is the intriguing question that I get asked pretty much daily, if not hourly. Does the equipment fit in the room? Well, strangely enough, the simple answer is 9 times out of 10, yes, the equipment does fit in the room. The problem is that we tend to forget about the ancillary equipment that's going to go in there. So I just want to demonstrate, I've got two scenarios here, one fairly simple with a CT suite, and another one which would be a little bit more complex with a theatre, where we can demonstrate, based on the equipment manufacturer's literature and possibly the HBNs, that this is a room size of 4 metres by 6. You can see that the CT fits in relatively well. We've got the computer cabinets in the bottom right-hand corner. We've got a dedicated control room. So it's fair to say I could categorically say, yes, the equipment fits in that room. Now what I did, just to demonstrate, when we include a workflow scenario, I've added what I would consider some pretty basic ancillary equipment to go in this room. So I've got some cupboards at the top, we've got a sink down by the doors, I've indicated a mobile injector and a mobile monitor, and then just demonstrated how you would get a patient bed in and out the room. So you can see straight away that we've got some problems. The bed, for instance, is a normal hospital bed size. Now to get that into the room, we're going to have to rotate the smaller of the double doors back further than the 90 degrees that is relatively standard. Obviously trying to avoid hitting the sink as you rotate that back. Once the bed is in position, then we've got a problem with the positioning of the sink and the clinical staff to transfer the patient from one side of from one bed to the CT table. The injector location is stuck where it is. It can't move. It's a mobile injector, but because of the size of this room now and the ancillary equipment that we've shown in there, it's almost impossible to move it out of that position. And the monitor, which would be normally on a monitor trolley, again, it's stuck. It can't get around the foot end of the table, and up by the gantry, you can't move it around there. So based on this 6 metres by 4 metres, you can categorically say it's not big enough. It's big enough for the equipment, but when you add the workflow scenario, it definitely isn't big enough. And this is just one example that gets overlooked, especially when we're designing rooms and hospitals. This is a more complex scenario where we've got a theatre, and this is one of the situations that's cropping up more and more often. We have a 9 metre, what have we got? 9 metres by 5.5 metres theatre with an anaesthetic room and a prep room. And in that theatre, you'd have the operating table, several people around the operating table working on the patient, several different mobile trolleys scattered around, the blue with the funny arms coming off from the ceiling-mounted pendants. So there's quite a bit of gear already in the operating theatre. Now, what's happening more and more often with these rooms is that we're getting a request to turn them into what we would consider a hybrid OR lab. which in theory, again, this is a typical example of what a hybrid OR lab could look like, with a dedicated C-arm in the corner, but you've still got the conventional operating theatre equipment as well. So when we add all that equipment to our plan now for a C-arm, it could either be ceiling mounted or floor mounted, you'll see that, yes, again, the equipment fits, but now we've got more problems. With a dedicated C-arm, you need a control area, and you've also got computer cabinets that need to be located somewhere. The computer cabinets have been indicated in the top left-hand corner. Now, again, in an OR environment, it is pretty much forbidden to have these exposed because of infection control. So what we would have to do is either put an enclosure around those or have them separate outside the room. The control area, we've shown it relatively large on this situation, and it can be considerably smaller, but it just depends on the specification of the equipment. If you want all the bells and whistles with this system, you're going to end up with a control area of that sort of size, which is quite large, but you can't avoid that. The C-arm position. In an OR environment, the C-arm needs to be parked well out of the way of the operating table. If you can't park the C-arm out of the way, the operating table really becomes useless. So we need to get that as far as we possibly can. So consideration needs to be where we park the C-arm. You can see the light blue is really, this light blue up here is basically the C-arm position in its park position, but it's now directly in front of the prep room door. And last but not least, people. There can be a considerable amount of people in this room, lots and lots of clinicians. I've known this room to be full of at least 20 people sometimes. So these are the two scenarios that I really want to highlight, that yes, the equipment fits, but when you add ancillary equipment, it may become impractical from a workflow perspective. So I'm often asked, how do we get a specification for a room size? And the literature is pretty thin on the ground, I must admit. We've got two main sources, obviously manufacturer's literature, which is ours, which is fine, and health building notes. The manufacturer's literatures, we're going to be biased. Every manufacturer will be biased. We want to win the business. Basically, you will find in the manufacturer's literature minimum requirements. Occasionally, you will see a recommended room size, but minimum requirements, which again is fine, but not necessarily for the workflow perspective. Also, in the HBNs, you will see those minimum requirements slightly larger, but I wouldn't necessarily use them strictly. As we heard earlier, they're a little bit out of date. The room size might be big enough, but you do get irregular room shapes and sizes. So my message to everybody is to get the manufacturers involved as early as possible in any project so that we can give you at least some guidance on our equipment, if not necessarily on workflow. We've got expertise in our organisation which can help with workflow, but mainly on the equipment size, at least we can give you some guidance on the size and shape of rooms. I've put this topic in because it's always slightly contentious, because it can be misleading in several different ways. The brief from the customer. Now, it sounds obvious to most people, but the brief from the customer to us as equipment manufacturers is critical. And the clearer and the more precise instructions we can get from you as the customer, the better your layout and design is going to be, and therefore preventing possible modifications further on down the line. If we do have to make modifications, which is quite often the case, there could be cost implications. Depending on the type of modification, how large it is, there could be an awful lot of costs. But more so, we're looking at potential timescales, time delays in the overall project, because you can guarantee at a very early stage there'll be a program involved, and at the end of that program there will be a clinical go-live date. If we prepare one design for a department and it's got to be changed several times, by the time you go back through the user groups and get approval from them, you're losing time. The clock is ticking, and at the end of that time there could be penalties to pay if we've missed that program. Now, that all sounds very easy, but there are obviously complications to larger projects, in particular the PFIs. So the brief from the customer at the PFI maybe 6 or 7 years ago may be very different to what it is today. So if we started off in a PFI, say in 2005, you may find that the design team originally in 2005 and the clinical users, they've moved on. They're no longer with that hospital trust anymore. So what was their thoughts of how the hospital and the room should be designed 5, 6 years ago may have changed totally now. The new clinical design team may have totally different ideas. And you've also got to bear in mind that we're working in an evolving market. There could possibly be bigger and better equipment out there compared to 5 years ago. Therefore, we've got to consider that when we're designing these and try and implement some flexible space. Just picking up on the evolving market, also new clinical techniques. You know, again, what was considered perfectly normal 5 years ago could be totally different now, and therefore the workflow of the whole department might be entirely different. So just mentioned it a minute ago, flexible soft space. You know, you hear this mentioned more and more often when we're designing hospitals. Can we put in some soft space? This soft space is what I would consider offices that aren't going to be used or storage rooms, but if it's in there and we have to change the design at a later date, the costs are going to be minimal to change it, and therefore I would always recommend to put some flexible soft space in. So the reason being for putting the flexible soft space in is the high risk equipment, and any one of these could be classified as a high risk equipment, but I would suggest that at a very early stage, find out from the customer in the brief if they're going to have an MRI scanner, because I would probably consider this the highest risk piece of equipment in any hospital radiology department. Why is it high risk? Well, twofold really. The effect of the MRI on the general public and the effect the surrounding areas will have on the MRI. So it's very, very important to determine at an early stage where your MRI is going to go and what location it's going to take up with regards to the adjacent rooms. Us as planners, we would look at an MRI scanner and we would make sure that the 0.5 millitesla line or the 5 Gauss line is contained within the MRI suite. It is a potentially life-threatening field that can affect pacemakers and ultimately cause death. Like I mentioned before, we try and contain it within the MRI suite, but if that's not possible, the MRI suite itself should be a controlled access, only accessed by staff or a staff member transferring a patient through to the MRI suite itself. This is a typical layout of an MRI suite. You can see from the red line, that's the critical 0.5 millitesla line, which affects pacemakers. Now, on this layout, we've got the MRI examination room in the middle. We've got a control console area at the bottom of the screen, and at the top we've got a technical room where we house our computer cabinets. Okay, you could say, well, you've just mentioned we've got to contain the 0.5 millitesla line within the examination room, and you can see it doesn't quite fit in the room. The red line protrudes further out the back of the MRI scanner itself. That is okay because it's actually in what we would consider the MRI technical room. So in theory, the only people that should be going in there is the equipment manufacturers, engineers when they're servicing the MRI, or maintenance, or changing parts, etc. However, if other staff are going to wander into that back room, because that 0.5 millitesla line drifts into there, again, it has to be under controlled access. Key lock or a person in the department with just the key. You've also got to consider that this 0.5 millitesla line is not just on a 2D plan view, it's 3D. So you would need to look exactly what's above and what's below this MRI scanner to deem whether it's safe to put the MRI scanner in this location or not. You'll notice that I've tried to position this on sort of an outside wall, mainly for delivery. We've touched on it very, very briefly in a few other presentations, but an MRI can weigh anything up to 13 to 15 tonnes, and normally speaking, these MRIs are craned in and then push through a hole in the wall. If you've got to push a 13 to 15 ton magnet through a whole hospital department, it's going to. So I would always recommend we get this MRI suite on the outside of the building. So we touched on the effects that it would have on the public, which is the 0.5 millitesla line, which you can see that affects pacemakers. Now I want to just show you a couple of charts. The disturbing influences on the magnetic field from other items outside of the room. So for instance, yes, I've mentioned let's have it on an outside wall because it's perfect for delivery, but let's not have it on an outside wall next to the M6 because you'll have cars whizzing up and down there which will affect the magnetic field and therefore distort images and could potentially make the MR totally redundant. So there's this list here on the left-hand side, table 3, indicates the sort of distances that certain items need to be away from the MRI to avoid the magnetic field being disturbed. For instance, you can see cars up to 900 kilograms, which is a pretty standard car, needs to be 5.5 metres away in the X and Y direction of the magnet and 7.5 metres away in the Z direction. So that gives you a basic outline. I mean, streetcars and trains, streetcars obviously being trams and trains, they need to be even further away. The chart on the right-hand side gives you an indication of other medical devices that need to be outside of the magnetic field lines as well to avoid their process being disturbed. For instance, if you've got a colour monitor that's within 0.15 millitesla, within the 0.15 millitesla line, you will probably see that the colour monitor will start to flicker. Linear accelerators, they need to be outside of that area, otherwise it's going to affect them as well. So there's lots to think about on positioning this high-risk equipment, certainly on an MRI scanner, and I would always recommend that if you've got the brief from the customer that's saying we want an MRI in our radiology department, you start with that. You forget fluoroscopy, forget CT, MRI needs to be in position first. It's highly important to get that in the right position. So I've just got some key points here for MRI planning that we've already touched on. Plan the MRI on the ground floor with the external wall but away from cars and lorries. Try to contain the 0.5 millitesla line. Like we said, if you don't contain this, it needs to then have a controlled access. You can contain the 0.5 millitesla line by additional iron shielding. This is costly and it's also very heavy. So when you're considering the weight of the MRI of maybe 13 tonnes, and that's an extreme case, you could also be looking at another 10 to 15 tonnes of additional iron shielding. So it's vitally important that if you can contain the 0.5 millitesla line, it would eliminate the weight issue. Consider the delivery routes and the weight of the scanner that we just mentioned. Ensure that you've got it in a controlled area. Now, most MRI scanners are in a controlled area. Normally speaking, you would have a lobby area directly outside of the examination room. This lobby area is purely so that the staff can escort the patient through safely. The suite should contain its own facilities. Again, depending on the brief from the customer, I would always recommend that you've got changing cubicles in an MRI suite actually past the controlled doors, and also a locker area so that the patients can put all their valuables, because you can't take metal objects into an MRI room, all their valuables into a locker, etc. Non-magnetic ancillary equipment only. This sometimes gets overlooked, especially when we're designing rooms, and certainly architects and designers, this does get overlooked. When a patient comes down potentially from a ward, it's on a normal hospital bed. That normal hospital bed can't go in an MRI scanner. It will be attracted to the magnet like no tomorrow. So that patient has to be transferred over to a non-magnetic trolley. You need space for this, and it could be quite a large space that you require. So it needs consideration. The impact it will have on the adjacent rooms. So, for instance, you can have an MRI scanner, you may have a CT scanner right next door. Again, it's not too much of a problem as long as you keep within those distances, or outside of those distances, I should say, that I put up on the screen earlier. Determine where the existing services are. Yeah, another one that's overlooked. High voltage cables. If you've got power cables running over the top or underneath the MRI, it will affect the image quality. So we need to maintain a certain distance for these cables, even ductwork. It's all metal, it's all going to impact on the image quality of the MRI scanner. Establish a sensible quench pipe. For those who don't know, a quench pipe is the emergency extract of helium directly out through the MRI scanner itself. This quench pipe is attached to the MR, but also needs to get access to the outside world so that helium can be extracted, if necessary, directly into the outside world. Now, this quench pipe route could be 50 to 100 metres long. The longer it is, the bigger it gets. I have known pipes to be 500, 600, 700 mil in diameter on their own, and then on top of that, you'll have additional insulation and ducting around it. So if you're going directly up through a hospital building, you need a service void of maybe a metre square. So another reason for putting the MRI on an outside wall, so the quench pipe can be just poked straight through the wall and up the side of the building. So that's really about it on the high-risk equipment and planning. I just want to move on to pre-installation requirements. I can't cover all of them in this timescale, but these are certainly the key ones that I would always sit down and discuss with the design team, certainly on the M&E side. So we've got electrical, structural, mechanical, environment, and the radiation protection. Start with the electrical. In place at the moment, there's the IEE regulations, and it was spoke about this morning, the Megan, which it's a guidance, but we are strongly recommending that every single imaging equipment room, it conforms to Megan. Certainly on all the installations that we're doing at the moment, we are almost insisting it as a company because of the safety factors involved. Things to consider: our equipment and all other manufacturers' equipment could even be three-phase or single-phase. Sometimes this is overlooked. Sometimes people think MRI scanner, wheel it in, plug it in the wall. It's not that. It's a huge, great big power supply. It could be up to 250 amps, which is quite considerable. System UPSs. This is becoming more and more of a trend recently on angiography and cardiology, with the whole system going on a UPS system, because obviously we've got the need to finish off a case with patients. The problem is UPS systems, if you're going to truly back up the whole 250 amps, the UPS systems are enormous, and they will need a room probably the size of this seminar room. And moving on to structural, the weight of the equipment on the floor. I mean, again, it gets overlooked. The weight of equipment is coming down over the years, but I wouldn't say enough to say any old floor will take the weight of the equipment. So it needs to be considered. Research needs to be in place. Structural engineers need to be on board. Also, the weight of the equipment on the ceiling. This often gets overlooked. You may think about the system being positioned on the floor, but you'll also potentially have monitors and maybe another C-arm system hanging from the ceiling. You could have 2 tons easily hanging from the ceiling. The dynamic load. So it's not just the dead weight of the equipment that we need to consider on the floor and the ceiling. It's the dynamic loads as well. It's when the equipment moves around the room. And it sometimes gets overlooked purely because somebody will say, oh, well, that's 2 tons hanging from the ceiling. Yeah, that's fine, but it's also moving to one end or the other of the room, and it needs to be considered. We always need a floor screed for trunking routes, normally to the base of a table. I say always because that's been the way in the past. If you haven't got a floor screed, then you have to still get cables to the base of the table. There's only 2 other ways of doing it. You either run the cable across the floor and becomes a trip hazard, or you go down through the slab, and then come back up again directly where the hole needs to be underneath the table. Going down and up causes other problems, especially if you've got departments below. You then got to get access to those departments. So I would always recommend a floor screed, and hopefully to a sensible depth. And I say sensible because sometimes we see floor screeds of 10 millimetres, which is no good for these cables. Structurally suspended ceiling. We touched on this earlier, on the weight of the equipment on the ceiling. You need a suspended ceiling, obviously, and it will need to be a structural load-bearing ceiling if you're going to hang equipment from it. Some equipment nowadays also is vibration sensitive, so it's still not too many pieces of equipment that are vibration sensitive, but it still needs looking at an early stage. Certainly on new builds where the common practice is to have very, very large spans between columns and a thin concrete slab. And then the delivery routes, mainly really for the MRI scanner, but you could consider quite a lot of other equipment in that which are quite bulky that will need to be wheeled through a hospital department. Mechanical. Some equipment require water chillers, or it can be run off the main hospital chiller. If it's run off the main hospital water chiller, can pose other problems purely because you need to make sure that you maintain water quality, the pressure, the flow rate, etc. And if you haven't got a dedicated water chiller, this is sometimes difficult to achieve. The pipe work to and from the water chiller, who's going to run it? Somebody's got to do it. Now, if it's a turnkey project, it's no problem. It's covered under the equipment manufacturers. But if it isn't, this normally falls between two stalls where we might be supplying the water chiller, but we're not supplying the pipe work. So it needs to be considered. The quench pipe route, again, that we mentioned earlier, and air conditioning units. Most equipment requires air conditioning nowadays. Certainly more and more equipment is going away from the water chiller idea and moving into sort of larger air conditioning units. Heat dissipation and the environmental conditions. Heat dissipation, it could be as much as 15 kilowatts to the air, depending on the type of equipment, which is quite a lot. So to actually get rid of that heat that's being dissipated in that room will take a very large air conditioning unit if it's not designed carefully. Humidity requirements. Some pieces of equipment have very, very stringent humidity requirements, otherwise they just simply won't work. And the operating temperature requirements. Again, not too much of a problem on most equipment, but there are some of the high-risk equipment where the operating temperature requirements can be quite narrow, maybe even 4 or 5 degrees maximum. And lastly on this one, I've put radiation protection because this is one item that tends to get overlooked quite often. We're all very, very happy with the layouts, everybody's approved them, and then at the last minute somebody says, has anybody pushed this under the nose of the radiation protection advisor so that he can confirm if the control area is in the correct place? And so I would always recommend get the radiation protection advisor on board as quickly as possible. He'll determine the thickness of lead that's required in the walls, the operator protection, maybe a lead protection screen for the control console, and also he'll give you advice on the X-ray warning light locations and the type, together with the emergency stop buttons. So I'm going to kind of end with my presentation here. What does the future hold? Well, this is, again, another intriguing question for me because I'm being told from designers new equipment is getting smaller, isn't it? Well, the simple answer is no. It's not getting smaller. If you consider the PC that you've got at home, that maybe you had a PC 6 years ago, has that PC now got smaller? If you go and buy it new in PC world, no it isn't. It could be smaller, you could have a nice laptop. But basically what we're finding is the equipment, the physical size of the system is actually remaining roughly the same size. We're finding the computer cabinets that is running and driving that equipment are getting smaller. So years ago you may have had a 1.5 Tesla magnet which may have had a room full of cabinets. You now got that same 1.5 Tesla magnet, but the cabinets could go in a corridor or in a very small cupboard. Likewise with a biplane system. We used to have huge computer rooms to run a biplane system. Now we could be down to 3 or 4 cabinets, which is very, very small. So my answer is no, the equipment is not getting smaller, it's getting more powerful. So thank you very much.